So I'm going to look at 38 on that second page. On 7-4. So it says y to the 2n minus 16 y to the n plus 64. Now, if you look at your algorithm sheet, you know, this thing is, it's a trinomial, it's descending order, and there's no common factor. That's what you want to always make sure that there is. It's not a binomial, it's a trinomial. When it's a trinomial, your algorithm sheet says check for special case. It says, is the first term a squared term? Can you write that first term as a squared term? Okay, Caleb, you said yes. I saw you shaking your head yes. Is that right? No. You were just saying wonder how. Right? Okay. Anybody know how? Well, if you look at that little box at the bottom, you remember that you can write this as y to the n to the second power like that. Now that's a squared term, isn't it? You're squaring y to the n. Does that make sense, Caleb? Okay. Now notice that then you can go minus 16 y to the n. So this y to the n is what you're, you know, it's like a squared minus 16a plus 64. So the first term, when you look, you say, is this a special case? That's what that, you go down in your algorithm sheet and you go to, I don't know, like 6, I think 6 or something like that, and it'll say it's a trinomial, is it a special case? Well, a special case has to be a squared first term. The trailing term must be squared. Is 64 squared? What is squared? 8. So you got a y to the n that's squared here. You got an 8 that's squared there. Now, the middle term has got to be 2 times the first squared term times the last squared term. Is 16 y to the n and 2 y to the n times 8 same? The middle term is 2 times the first times the last, right? And so what it's saying is that when you have a squared minus 2ab plus b squared, that's going to factor into a minus b, the quantity squared, where your a is going to be this value and your b is going to be this value right there. So now what you do is a minus b quantity squared is what? The a is what? yn minus the b is 8 quantity squared. And that's how that thing factors. It's a special case trinomial because it fits the pattern. Notice that it has to be a plus right there too. Forty says 16 minus a minus 3 squared. Now that algorithm says expand everything. And you could do this by expanding. You'd have to go 16 and then you'd have to go minus, and then a minus 3 squared is the first term squared minus 2 times the product of the first times the second plus the second term squared. And then you go 16 minus, change the signs of everything inside. And then combine terms, and then do it, right? You could do it that way. And then you factor out a negative, right? So that your leading term was positive. Then you go a minus 7 times a minus 1, right? Plus 1. You can do it that way. Isn't that right? Now, the other way you could do it is if you see this as a binomial. Do you see this as a binomial? 16 minus a minus 3. It's a binomial set of terms. If you think of this as a squared minus b squared. Why am I saying squared? Because 16 is actually what squared? 4. And this is a minus 3 quantity squared. Isn't that right? Now, look at your binomials, a squared minus b squared. How does it say that factors in your algorithm sheet? A binomial difference of squares always factors out. A plus b, a minus b, is that right? Where a is what? 4, and b is a minus 3, right? So let's put it in there. So a is, what did I say a was? 4 plus, and b is what? A minus 3. And then a is what? 4 minus a minus 3. Notice that first term, if you drop the brackets, it's 4 plus a minus 3. So what is that? 1 plus a. In the second term, this one, if I drop the brackets, this one is 4 minus a plus 3. Is that right? So it's 7 minus a. You see, if you run that minus sign in here, you'll get 7 minus a, won't you? And then you get a plus. Now, if you're able to do this, and you go this to here, then from here down to here, and then go to here, it's a whole lot faster than to do this thing. From here to here, down to here, down to there, down to there, down to there. So either way is right, isn't it? You get the right answer. But you can speed your process up. So does 42 fit into the pattern, just what I did right here? Number 42. Could you think of that as a binomial difference of squares? Number 42 on your sheet. X minus 2y, the quantity squared, minus x minus y squared. Can you think of that as a binomial difference of squares? What would the a be? X minus 2y, wouldn't it? And the b would be what? X minus y. This would be a, this would be b, and it would factor into a plus b, a minus b. And you just put this value for A and that value for B, right? I hope that wasp is one of you, not me. Everybody's hot. Anyone allergic to wasp bites? Oh, Aaron's watching it close. Oh, you better watch close. So, you want me to do that one? Quick. So you see, I'm going to put A is x minus 2y. So I'm going to go this bracket, then I'm going to go x minus 2y plus, and then B is x minus y. Now I've done this much right here, correct? Now I'm going to do A minus B. I'm going to go x minus 2y. That's the A minus x minus y. You see that? Now if I drop my brackets, notice the signs don't change on the first one. So what do I have? 2x minus 3y, is that right? Then the second one, now I better do a little bit to this, otherwise I'll make a mess of it. X minus 2y, and that minus sign in front of there means I changed the signs. A minus x plus y, is that right? So notice my x's go away. You know, I wrote this problem wrong, but if you're just watching the problem, this should have been a plus. But we'll just go with what I wrote down, because it makes no difference. The x's go away, and I have a negative y. So the problem is going to be a little different answer here than what's in the book, but you get the idea of what you do. All right, now then, the next group of problems is the sum and difference of squares. Now notice that when you go sum and difference of, cubes, the next one is cubes. When you go sum and difference of squares, the difference of squares factors, but does the sum of squares factor? On that algorithm sheet it says if you have a sum of squares, it's non-factorable. Now on sum and difference of cubes, that algorithm sheet says this: if you have a difference, I want to stay with a cubed minus b cubed. This is going to factor into a minus b, a squared plus ab plus b squared. Right? And then the sum of cubes is going to factor into a plus b, a squared minus ab plus b squared. So unless you want to learn all of those factoring rules, you probably better take your algorithm. Now, another thing that you have to kind of get down is when you cube 1, what do you get? 1, right? When you cube 2, what do you get? Two times 2 is 4, 2 times 4 is 8, right? When you cube 3, what do you get? $27. When you cube 4, what do you get? 4 times 4 is 16. 16 times 4 is 64. When you cube 5, what do you get? $125. So when you're doing a cubed plus b cubed, what numbers are you looking for? If you're looking for numbers, these numbers cubed, then you're going to see these numbers, right? You understand? See, if you're given x cubed plus 125, then what do you know it is? You know it's x cubed plus 5 cubed. So a is x and b is 5. That makes sense? Those are and so 6 cubed, right? 6 sixes are 36, and 6 times 36 is 218 or something like that, right? So you'll see these big numbers when they're cubed, but you have to realize that you're not dealing with squares, you're dealing with cubes. So let's look at 46. 27y to the 15th. And they're saying, what is the cube root of that? In other words, this is the way you'd ask that question. The radical sign with an index of 3, that's the cube root of it. So what you'd want to know is 27, is 27 something cubed? It's 3 cubed, isn't it? 27 is 3 cubed. Now can you write y to the 15th as a cube? Oh, look, you can write y as 3 times 15, right? 3 times 5. And then this is y to the 5th cubed, right? Isn't that right? You know, if you look at the bottom of that algorithm sheet, that little square thing says that you can write 15 as 3 times 5, and you can write this 3 times 5 as either this way, or you can write it this way, y to the 3rd to the 5th power. So y to the 15th is either the 5th power of y to the 3rd, or the 3rd power of y to the 5th. Well, which one are you going to want to use when you're doing cubes? The 3rd power of y to the 5th, right? You're going to want to write this in here as y to the 5th to the 3rd power. And then when you take the 3rd root of it, what's the 3rd root going to be? 3y to the 5th. Okay? That's what you're going to have to look at in these problems. So 50 says y cubed plus 125. So that's a polynomial. That's a binomial, has no common factor. So it's a binomial, and so in binomials, the special cases are binomial difference of squares, sum of squares, difference of cubes, sum of cubes. Is this one fit? Any one of those three. Well, your question should be, is 125? Is 125 a cube? What is cube? 5. So 5 cubed plus y cubed. So which one of those 4 is that? It's the sum of cubes, isn't it? Well, what's being cubed in the first? Y is. What's being cubed in the second? 5. So this is A and that's B, right? Now, what's the factoring of difference of cubes? It's A, of sum of cubes. It's A plus B, B, and then it's what? A squared minus AB plus B squared. So how am I going to write this? A is what? Y plus what? 5. And then it's going to be Y squared, because A is Y. And then it's going to be Y times 5. Well, I'm going to write that as 5Y. Is that right? Community property multiplication. And then the last term is 5 squared. 5 squared is what? 25? So there's the factorization of that problem. And you use your algorithm sheet, you just find it, figure it out, find out what A and B is, and set it up. (54) says x cubed minus 8y cubed. Now that's a binomial, isn't it? There's no common factor in there. You always want to make sure that you've got the common factors out. Now the question is that a binomial, and it's cubed in the first one, so is the binomial difference of cube? If it is, what is A and what is B? Is it a binomial difference of cubes? Is it? Well, the first term, it's a cube, right? What's being cubed? X. Is the second one a cube? What is cubed? Being cubed? 2y, right? So that's a binomial difference of cubes. How does it factor? What is the AB representation? A minus B, right, times A squared plus AB plus B squared. So what am I going to write? A is X minus B is (2y), isn't it? See, it's just plain AB. This is the B, this is the A. It's what's being cubed.
Okay. Okay, yeah. I see.
Then it's A squared, so the A is, which one is? The X, right? So it's X squared. Then it's plus the product of X times 2y. How would you write X times 2y? 2xy, wouldn't you? You'd write the product of these two, X and 2y, as 2xy. I mean, you could write it as X times 2y, but that wouldn't be the way you'd want to have it look, right? And then it's going to be B squared. Well, which is B? The 2y. So if you square the 2y, what's it going to be? 2 squared y squared, isn't it? Which is 4y squared, right? Okay, look at 60. 64 x cubed plus 27 y cubed. Okay, if the first term has a variable that's cubed, then the question is the rest of it a cube? Is the 64 a cube? If so, what's being cubed? If you know, tell me. Don't just look at me.
Wasn't
Remember 1, 2, 3, 4, 5, which one?
4.
It's 4, isn't it? This is a 4x. That's A, isn't it? Because 4 cubed is 64. Now, 27y, what is, it's a 3y, right? What is, this is the A and this is the B, correct? Now notice that this is a sum, so how is it going to factor? A, you just go to your algorithm, you should have that sheet. A plus B, and then it's going to be A squared minus AB plus B squared. That will be right on the algorithm sheet. So now what are you going to put? You're going to put A, you're going to put what? 4x plus B is 3y. A squared is going to be 4 squared x squared, right? So that's 16x, right? Squared. It's 4x squared. How are you going to write the product of this one and this one? 4 times 3 is 12xy, aren't you? And then it's going to be plus the b squared, which is 3 squared y squared, which 3 squared is 9y squared, right? Now, if you can't figure it out, write it in. Write this one as 4x, the quantity squared. Write this one in as 4x times 3y. And write this one as 3y, the quantity squared. If you can't, if you can't get it figured out. Otherwise, just do it in your head. We'll look at 64. 27x cubed minus 8y squared, y squared. Now notice the first term is a cube, isn't it? What's being cubed? 3x, isn't it? Now, be really careful. Is the second term a cube? No. The 8 is a cube. It's a 2 cubed, right? But it's y squared. So this is non-factorable. Because it's not the difference of cubes. So be pretty careful when you're doing it.